These look like they'd take forever, but they're really quick. The hardest part is graphing it, but your graph's done. All you gotta do is plug it in. So you look at 6, right? That's about here. And 0.8, so that's about here, okay? Then you got 21, it's right here. And 0.6, that's right here. Okay? Then you got 26, that's halfway across, a little more, and 0.5. 58, almost to 60, and then to 0.1. Okay? 60. Oh, whoops, that's a 0.2. 62, 0.1. 79, 0.1. 89, 0.1. 90, 0.1. And 90.2. All right, so is this linear? Okay? So is this linear?
No.
Now, this is kind of a weird one. At your level, I could totally see you seeing this as linear correlated, right? I could see it. Now, what they want you to see is that it comes down and it goes like this. Does that make sense? Are you watching? It comes down and goes like this. And the reason they're doing this is later on, okay, later on, they're going to be talking about exponential functions. Okay. We know how we've talked about exponents, right? Exponential functions are functions where you have the x as an exponent, right? So a lot of times what's happening is that it starts out really big, which would be some number, and then as you put the exponents out there, it's going to come down. Now, in this case, it wouldn't be 3, it would be, looks like it would be...
Why is that something different?
Because it keeps getting smaller and smaller the bigger the number gets, right? So it gets smaller and smaller and smaller, and then it levels out. And that's what happens with an exponential function. Now, is this linear? No. So it's non-linear. Okay? So they want you to say that it's a negative, because it goes down, right? Negative, non-linear function. Now in this case, if you do call it nonlinear, then you could call it exponential. Okay? And at that point, you could say your R value is pretty tight. So it would be a negative 0.8. Okay? Now, what if you just thought it was like this? Would that be linear?
Yeah.
Yeah. So on your test, if you said, hey, I cut the data in half, I noticed that it's a negative linear correlation with an R value of approximately negative 0.8 or 0.8, okay? And I would say, okay, I'll accept that. But you gotta draw your line, cutting the data in half. I could accept that on this one. Now some of these data is gonna go like this, right? It's gonna go like this, and then it's gonna go like this. Now at this point, it's not linear at all. This is non-linear. Anytime you have data like this, that's non-linear, okay? So we'll talk about what type of curves they are in the future, okay? So square root functions look like this, right? Exponential functions look like this. Quadratics look like this. Cubics look like this. Okay? So we will talk about those different things. But just so you know out there, This again is a square root. Okay? This is exponential. This is quadratic. This is cubic. Alright? And those are your nonlinear functions we're going to be talking about. Okay? Now obviously, this would be a positive square root. This might be looked at as a negative square root, which there isn't one, but we'll talk about that. Well, there is actually negative square root. So it'd be more like this, and then here would be a negative exponential, or like this, a positive exponential function. This is what we call positive because it smiles at you, right? Or a quadratic like this, which frowns at you. Okay? So that would be negative. Right? And then this is a cubic. Now, believe it or not, this is a negative cubic. Oh no. Yeah. Because it goes down at the end. This is a positive cubic. So this one's negative, and this one's positive. Okay? So those are your different functions, your different types of nonlinear functions, okay, that we might ask about. So you need to keep that in mind. That's it. Yes, ma'am.